Now, in this video, we will going to take up one more problem on the cantilever beam, the problem number 3. Find the reactions at the fixed end and draw the SFD and BMD for the cantilever shown in figure. So here we have a figure of cantilever having fixed at one end A and the other end B is free. We have a set of we have set of point and UDL loads. So 0.3 kilonewton, at the point C, the 3 kilonewton is acting downward from the point A, which is at a distance of 1 meters. Similarly, the commencement of UDL will start from D, which is at a distance of 2.5 meters. Then the UDL will going to enter the point E, which is at a distance of 4.5 meters from A, and the uniformly distributed load is of 10 kilonewton per meter over a span of 2 meters. Similarly, at the point B, which will going to be a load of 2 kilonewton, which is acting at a distance of 5 meters from the fixed end A. Now we need to find out the reactions at the fixed end. So what are all the reactions you will going to get at the fixed end? The reactions what you will going to get as the load as the beam should be in equilibrium condition. So that means all the loads are acting downwards. So naturally you should have a load which is acting upwards. Should be RAV, which is acting upwards. Then as the load is acting downwards, so the bending moment of the beam will try to be rotating in clockwise in order to keep the beam in the equilibrium condition. That means even after the application of load, the beam should remain same or straight. So for that, we need to have a reactive moment which should be equal to counterclockwise direction, which is equal to MA. So we need to find out that reactive moment also. So now first we will going to take up the reactions at the fixed end. So as there is no horizontal load acting on the beam, so sum of the horizontal load, that is sigma h, will be equal to 0. As there is no load acting on the beam horizontally, so therefore RAH will be equal to 0. Now, since all the loads are acting downward, so therefore you will going to have the reaction at the fixed end acting upwards, which is by signing convention, we will going to take that as the positive value. So that means sigma V, the summation of all the vertical loads will be equal to 0. Therefore, so by convention, the load acting upwards is positive and the load acting downwards is negative. So therefore, in this case, RAV will be equal RAV plus, so RAV minus the loads acting on the beam, which is 3 next minus 10 into 2, because UDL will going to act over a span of 2 meters. So since it is 10 kilonewton per meter for 2 meters, it will become 10 into 2, which will be 20. Then the load acting downwards at the point B, which will be equal to minus 2. So therefore, which will be equal to 0. So on simplification, RAV will be equal to 25 kilonewton, as it is positive, therefore it is acting upwards. So therefore RAV will be acting upwards by 25 kilonewton. Now we need to find out the reactive moment. Since all the loads are acting downwards, so we're going to have a clockwise moment. So in order to keep the beam in the equilibrium condition, so we at the point A, you should have a reactive moment which will be in a direction opposite to the direction of the application of load. So since the direction of application of load is the clockwise, therefore the reactive moment will be in counterclockwise direction, so that the beam will going to remain straight even after the application of load. So therefore sigma m will be equal to 0. The sum of the clockwise will be equal to sum of the counterclockwise. So according to this equation, sigma m, the load into the perpendicular distance, so that will be equal to minus ma, because it is in the counterclockwise direction, taking the moments about the point A. So what happens? Minus ma plus 3 into 1, that is the load into distance. Then minus, so again, since the load is acting in the clockwise direction, plus 10 into 2 into, then open the bracket. Here the always UDL will act at the midpoint. So 2 by 2 then this load should be with respect to the point A because we are taking the moments about the point A. So 10 into 2 into 2 by 2 plus 2 by 2 plus 2.5 plus 2 into 5. So that will be equal to 0. So take on the simplification side, MA will be equal to, you have 3 plus 20 into 3.5, that is 60.5 plus 10, 70.5 plus 3. So now we will be equal to 83 kilonewton meter. So you will going to get 83 kilonewton meter as the reactive moment is positive, and therefore in the reactive moment it will be in counterclockwise direction. So this is how you will be able to analyze the reactions at the fixed end. Now we will consider the shear force and bending moment diagram. So the beam is, this is the actual beam what we have. First we will going to consider from the free end between E and B. So when you are considering between E and B, E, it is the starting ending point of the UDL. From we are going from the right to left now. Considering between EB, as there is no other load on E, so you will be having only E point. And that distance of B will be 2.5 meters and this 2 kilonewton which is acting downwards. So then what will going to be the shear force diagram at the point B? If you take this section, and if you try to apply, so since it is in the downward direction, so it is positive. So shear force at B will be equal to plus 2 kilonewton. As is there any load between E and B? No, it is constant. So therefore, between B and capital E, it is constant at plus 2 kilonewton. So what will going to be the shear force at the point E? The shear force at the point E will be equal to, again it is 2 kilonewton. Why? Because as there is no other load is acting at the point load E. So on simplification, so now we will going to get the shear force diagram. SF at the point B is 2 kilonewton. Between B and E, it becomes 2 kilonewton. And SF at the point E also, as there is no load, it will going to be plus 2 kilonewton. Now, what will going to be the bending moment diagram? The bending moment diagram at the point B will be equal to load into the distance, as the load is acting at the point B itself. So distance is 0. Therefore, bending moment at the point B will be equal to 0. Now, what will going to be the bending moment at the point E? So as the load is acting downward from the top, so naturally the beam will going to tend to bend in the clockwise direction. That means it becomes hogging because the load is fixed at the point E, or the beam is fixed at the point E. So that will be equal to minus 2 into 0.5, which will be equal to minus 1 kilonewton meter. So when you are plotting this, so shear for bending moment diagram, BM at B is 0 and BM at E is minus 1 kilonewton meter. Now once you get that, now we go for then between D, E and B now. So when you are considering between D, E and B, then what is SF at D now? SF at D will be equal to plus 2 plus 10 into 2. So that will be equal to 22 kilonewton. So then what? So this is how, as it is a UDL, so from 2 kilonewton, it rises to 22 kilonewton because as the point load from E to D, it will going to be uniformly distributed load over a span of 2 meters. So since it is given as 10 kilonewton per meter over a span of 2 meters, so this 10 into 2, which will going to become 20, and this will going to be 2. So 20 plus 2, because all the load is acting downward to the right of the section, will going to be the positive value. So therefore, you will going to get plus 22 kilonewton. From 2 kilonewton, it shoots up to plus 22 kilonewton. And the law engineering between these two, it will going to be W into X. So since the power of X is 1, therefore you will get a linear line between E and D. So SF increases from plus 2 kilonewton plus 2 plus 22 kilonewton linearly due to UDL between E and D. Now, what happens to the bending moment diagram? The bending moment diagram is the load into the distance. So it is minus 2 into 2.5 minus 10 into 2 into 2 by 2. So that will be equal to minus 25 kilonewton. So here, so from this point, you have the BM at the point D. It as you have the uniformly distributed load from E to D. So therefore, since the power of X is 2, so from 1 kilonewton, you are plotting it to 25 kilonewton meter. As the distance is more, so it will going to be, since the power of X is 2, therefore, you will going to get a parabolic curve between the 2 points which are joining between 1 kilonewton meter to 25 kilonewton meter. So this is how. Once you do that, now we will go for the next consideration. So between D and C now. As we are considering between C and D, and it started from B towards C now. So here, what will going to be between between D and C now, as the load is acting till here, between B and C or D and C, as there is no other load is acting on the beam, therefore it is constant at plus 22 kilonewton. 22 kilonewton. So this is how you will be able to plot the shear force diagram till this point C. Now what happens to the bending moment? So the bending moment will going to be remains the same as there is no other load. So here, so what happens? So from 25 kilonewton meter, we want to get it to 58 kilonewton. So to do that, so here the bending moment of 25 kilonewton meter. Now from here, we need to go for the 58 kilonewton meter. So to do that, so what is that bending moment at the point C, which will be equal to minus 2 into, that is 2 plus 1.5 plus 0.5, which will going to become 4 meters. So that is minus 2 into 4, then minus 10 into 2 into 2 by 2 plus 1.5. So then on this simplification, you will going to get it as minus 58 kilonewton meter. As we plot this from 25 kilonewton meter to 58 kilonewton meter, since it is only the distance, so you get a linear line between these two. And here, since it is the UDL from 1 kilonewton meter, it drops to 25 kilonewton meter by means of a parabolic curve because the power of X is 2. So now, once you get this, now we will going to consider for the entire, now we considering the load at the point C now. So because in the earlier case wherein you didn't have the load, so only the distance, so the bending moment will going to be only that that particular point. Now we will going to consider the load at the point C now. Once you are considering that, what will going to be the SF at the point C now? SF at the point C will be equal to SF at the point D, it is 22, as the load is acting downwards, 22 plus 3, it becomes 25 kilonewton. So this is how it will going to become. So that is from 22 kilonewton, it rises to 25 kilonewton because due to the point load at the point C, which is equal to 3 kilonewton. Now what will going to be the bending moment at the point C now? So the bending moment at the point C will be equal to minus 2 into 4 minus 10 into 2 by 2 plus 1.5, which will be equal to minus 58 kilonewton meter. So that is what we explained in the last step itself. Now it is minus 58 kilonewton meter at the point C. So now once you get that, now we will go for the what is the shear force between A and C now. Because there is no other load which is acting between C and A, it remains constant at plus 25 kilonewton. So SF at the point A will be equal to, so that is 25 kilonewton. So once you get this, now when you are plotting it, so from 25 kilonewton between A and C, as there is no other load, it remains constant at 25 kilonewton. Now, what will going to be the bending moment at the point A now? So the bending moment at the point A will be equal to minus 2 into 0.5, sorry, minus 2 into 5 minus 10 into 2 into 2 by 2, which will going to be at the midspan from D. So with respect to A, so 2 by 2 plus 2.5. So 10 into 2 into 2 by 2 plus 2.5 minus 3 into 1. On simplification, you will going to get 83 kilonewton meter. So when you plot this, you will going to get this will going to be from 58 to 83 kilonewton meter. So since there is no load, it will going to have a linear line. So only the difference here, as there is a UDL from the point E to point D. So from 1 kilonewton meter to 25 kilonewton meter, the curve joining between these two will going to have a parabolic curve. That is basically because it is W into X by 2. So if you are considering in general, the power of X is 2. Therefore, you will going to get the parabolic curve between E and D. So this is how we will be able to get the final solution for this above problem. Thank you.